All right. How you going? So we're going to be doing the last problem for the compound mole lecture. So if we go to the last slide here, it's asking for a challenge problem with 16.29 grams of trizirconium tetraphosphate. How many atoms are going to be present for each of the elements present? So this large molecule here, we're going to need to figure out what each atom's number is for the elements present. So this is going to be quite of a decently long problem here, but if you can do this problem, you should be able to do any other problem that I present to you for this kind of lesson here. Now, things you'll need besides the problem here, so let me copy that because we're going to go to a whiteboard, is the periodic table here. So the periodic table of elements in this case. You're going to want the one that I have on Schoology, so please go to materials. It's the fourth one on your list. We're going to be using zirconium, which is the 40th element, phosphorus, which is the 15th one, and oxygen, which is the 8th element. And so let's get this onto a whiteboard. Oh, you also need a calculator, so I'll be using Desmos today. All right, so just so I can look at the screen while doing this. It's glitching out again. Hello. Why is it glitching again? Screen's paused. There we go. Okay, so problems. All right, so our problem is now here. So the easiest way to do these, to find the first step is to find molar mass. So step one, we need molar mass. Now, the easiest way I like to do this is to separate them out into each of their elements. So we have Zr, we have phosphorus, and we have oxygen. Now, we notice the 3 next to the Zr means that we're multiplying this by 3. The phosphorus is 1, but this 4 on the outside of the parentheses means we're going to have 4 phosphate. We have 4 PO4s here. So we're going to have PO4, 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 and PO4. So this means that there are 4 total. So we're going to be multiplying this by 4. Now, if you look at this on the right side again, we have the 4 oxygen molecules here. So O4, 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 and O4, which means that we're going to have a total of 12. So this will multiply by 12. Now, if you go to the periodic table again and look at the 40th element here, where's my share screen? Share screen, periodic table. We have zirconium, which is Zr 91.22. And we have 3 of those. So 91.22 times 3 will give you 273.66. So let's write that number down on our whiteboard here. So we have Zr, which was 91.22 times 3. At least that's what I believe it was. Yeah. And it gives us 273.66 grams per mole. Now, oxygen, I wrote that in the wrong parts. Let me see if I can drag it to the other area. Oh, so why did you move over there again? So this equals this number there. Phosphorus, if you look on the periodic table, so share, so we're back at Desmos periodic table. So P is the 15th element as 30.97. So we're going to have 30.97 times, we had 4, is 123.88. So this is going to be what we put back into our whiteboard here. So we have, so we said 30.97 grams per mole times 4 equals, what number did we say it was? 123.88 grams per mole. Now remember these sig figs that we're having here, the 4 for zirconium, the 4 for phosphorus, and the 4 that we're going to have for oxygen, and the 4 up here are going to be most likely what our final units are. So next, let's go back to the periodic table. And so now we need oxygen is 16.00. We said that there are 12, so we're going to do 16.0 times 12. So it'll give us 192. Let me share whiteboard. So we had 16.00 times, sorry, that's actually 16 because math. So I messed up. So 4 times 4 is not 12, it is 16, which means that this number will be times 16, which means we need to add 4 molar to our calculator. So we had 16.10 times 16 because it's 256. So we had 256.0 grams per mole. And so here we have our values. Let's add these up with each other. We will get 273.66 plus 123.88 plus 256.0 gives you, we're only going to take the first 4 sig figs here. So 653.5 is what I got. So this is our total grams per mole. This is a very large number. Now we want to know how many atoms are present for each of these elements. So we need to find moles. So I'm going to change the color here to, we'll say, orange. And so now we want to know moles. So step 2 is moles. So we need to find mole. Now remember, moles equal our mass divided by our molar mass. And so if you want to figure out how I got to that, you can also use the chart. But if we're following the units, mole is a unit. And so this equals grams divided by grams per mole. That's what molar mass is. And so if you follow just the units itself throughout the math, you will get moles on top and grams taken out. And so let's combine these. We have our 16.29 grams. And we're going to divide this by our 653.5 moles. And we will then be able to get our answer, which should be very small. So if you want to do this by yourself at the moment, please pause and do the problem. Otherwise, you can continue. Okay, so assuming that you've unpaused and you've done the math yourself, you should get 0.249. So we want 4 sig figs because each. And so it would be 27, but that is too many sig figs. We have 1, 2, 3, 4, 5. These do not count as sig figs because they can be removed via scientific notation. And so what we're going to do is we're going to round in this case. The 7 will become, we'll make the 2 a 3 for normal rounding here. And now we have a good amount of significant figures. And remember, this will be in moles. This is grams per mole. And so the grams will cancel out, the moles will go on top, and this is our moles for now. We are not done yet. We need to go to the next part. And so I'm going to open a new tab or a new whiteboard, and we will be able to move on from there. So step 3 is find mole of each element. So step 3 will be this one. Remember, we found for moles, so for ZR3, in parentheses, PO4, ended up, we ended up having, what was it, 0.2493. I left a 0 out. Moles. So this is how many moles we have. We need to figure out how many moles of each element there are. So now we're going to figure out for ZR. So for ZR, we're going to have 3 times the amount of moles in this case, because there are 3 sets of atoms, which means each one has this many moles of ZR. So there's 3 times that. So we're going to find, so we're just going to multiply the, I'll put a little red star for our value that we're putting in there. So this is what we're going to put in there to save space. And so our answer should come out, whoops, as times 3. We get 0.747, and we only want 4 sig figs. So we have this many moles of ZR. So we have one set, and so this can now let us figure out how many atoms there are, but we're not there yet. So let's go down to phosphorus. So remember phosphorus, there are 4 phosphoruses here, so we're going to multiply this by the moles. Let's get a little asterisk there so you know where I'm getting the value from. So again, this 0.2493 moles is what we're going to multiply by 4, because there's 4 sets of phosphorus. Each one has that many moles. And so let me gives us 0.9971 moles of phosphorus. I'll put those slashes in there so you know they're zeros, not O's. Okay, so next one we have our oxygen. Now remember, oxygen has that parentheses making their 4 oxygens in the PO4, multiplying that by 4, which means we need to do this by 16. Effectively, this will have 4 times the amount of the phosphorus number. So I'm just going to do a quick, easy times 4 there. And this gives us equals 0. Oh, wait. I'm forgetting a bunch of zeros here. My bad, guys. Should be another 0 there and another 0 there. So, okay, so now we're at, what's happening? 0.02493 times 16. My calculator just crashed. Okay, so we get 39888. We only want 4 of those sig figs here because that's how many we have for oxygen and for our whole number as a whole, and so of oxygen. So now we have our 3 moles. And so we need to multiply these by Avogadro's number in order to figure out how many atoms are in each. And so remember, we're going to multiply each of these answers by the number of atoms. We'll do this in dark green. So remember, we want Avogadro's number. Avogadro's number. And so I want you guys for the next, you can pause the video. I'll wait 10 seconds in the video, but I want you guys to figure out how many atoms are in each. And then in the description of the video, I'll have the answers. But this is effectively how you find the number of atoms of ZR in this case, number of atoms in phosphorus, and the number of atoms in oxygen. And so yeah, so the video should end in about a couple seconds. If you have any questions on, or I ended up making another error because I've already made 3 trying to film this, let me know and I'll re-upload with the correction. But other than that, hopefully this helps you guys out with the mastery you guys are working on and prepares you for whatever exam you're trying to do. But this should give you your answers for this. So remember, this was to answer the question of, with this many grams of this molecule, how many atoms are present for each of the elements present? So we wanted to know how many atoms there were. Step 1 was find molar mass. Step 2 was moles. Step 3 is find moles of each element. And then step 4 is go from moles to, I'll even write it down. So step 4, moles to atoms. So this should help you find the answer. And I'll see you guys in the next class period. Have a great day.